In this video, we're going to look at inheritance. So let's begin with an introduction to inheritance. So we know that duplicated code can lead to errors, right? There's more room for error. So let's say we have two classes, one class for sedan and one class for truck. And these two classes share a few properties and methods. Let's say methods like speed up and slow down. Okay, so if the method speed up has to change, okay, then we're going to have to change the code in every location where speed up is. So you have to go into sedan and change speed up. Okay, so maybe you want it to increase by 5 instead of increase by 10. Okay, so if that's the case, then we also have to go into truck now and make sure that speed up in truck also increases by 5 now instead of by 10. So the problem is that in other programs, it may be more than just two classes. So what if you had to change it for 10 different types of classes, or 10 classes? So maybe you have sedan, truck, van, and compact car, Jeep. So what if you have a whole bunch of them? Then you would have to go in and change it for every one of them. You might miss one or make a mistake changing one. So that just leads for a lot of room for error. So making the same change on code across multiple files is really a big waste of time, even if you made everything right, but really is a big risk for making errors. So that's why we have inheritance. With inheritance, you can define one superclass that contains shared members like speed up and slow down. So all classes that need those members can then inherit them from the superclass. So you have one superclass, then you have the other classes that inherit members from them, okay? So let's look at superclass and subclass. In inheritance, one class inherits the members of another class. So the class that inherits is called the subclass or derived class. The other class at the top is called the superclass or the base class. Okay, so this is the one that has all the shared members, and then the subclass or derived classes are derived from this superclass. All right, so before using inheritance, let's take a look at what each class might have had. So let's say the sedan class and the truck class both have wheels, they both have license plate, and they both have speed properties. Okay, and they also both have the honk method, they have the speed up method, and then they have the slow down method as well. And they also have similar constructors. So what you would do is pull these out of both the classes and then put it in the vehicle class. So the vehicle class would be the superclass. Okay, sedan and truck will still have access to those members that are in the vehicle class, the superclass, but you only now need to write them in one place. So all this, wheels, license plate, speed, properties, honk, speed up, and slow down methods, all only need to be written in one place now. Okay, so here we have the vehicle class. You have all that, wheels, license plate, speed, properties, vehicle, honk, speed up, slow down methods, all of them would be in the superclass, the vehicle class. And then derived from that, you can have the subclasses, sedan and truck. Okay, and in it, they would have all the same stuff from the superclass, and then in addition, their own method here, their own members here. So sedan would have the sedan method, and a truck would have the weight truck method. Okay, unique to each one of these classes, but still have all the others. So inheritance hierarchy can extend. It can extend either way. So a new pickup truck class could inherit from truck. So truck could also be a superclass to other subclasses, like say a pickup truck. And vehicle can also inherit from a class above it, a superclass above it, maybe something like called machine class, and it would inherit everything from machine class. Okay, A class can only inherit from one base class though. Okay? A vehicle cannot inherit from machine and contraption. You can only have one superclass. Okay? So to create a superclass is defined like any other class. Class, vehicle, okay, and all the stuff that goes in there. And a subclass inherits or extends, okay, a superclass using a colon syntax. Okay, so you have class, sedan is a subclass, and it inherits from vehicle, the superclass. So you use a colon to denote that. Okay. So you also want to implement an interface at the same time. So a class can extend a superclass and implement an interface with the same syntax. So you separate them with commas and make sure that the superclass comes before any interfaces. So this is how you would do it. You have class, sedan, okay, and then the colon, and vehicle, which is a superclass, and then comma and the interface. So what this means is sedan will inherit all the functionality of vehicle class, the superclass, and it promises to implement all the functionality in the iAutomobile interface. So let's take a second to review public and private before we move on. A public member can only be accessed by code. Sorry, a public member can be accessed by code outside of the enclosing class, right? And a private member is what can only be accessed by code within the same class. Okay, so let's remember that. So public can be accessed by any code outside of the enclosing class. Private can only be accessed by code within the same class. So if you have something like this, public, okay, double and then speed, okay, and you get, and then you have a private setter, you're going to get an error because the setter is private and you have to access it, right? So making the setter public though is not secure, but making it private is too restrictive. We only want the subclass to access, we only want the subclass sedan to access the property and not anyone else. Okay, we only want subclass sedan to access the property. So what do we do? So C# has actually another access modifier. To solve that, we have protected. Okay, it's called protected. So let's look at protected member. So protected member can be accessed by the current class and any class that inherits from it. Okay, so it can be accessed by the current class and any of the subclass that inherits from it. So if the setter for vehicle wheels is protected, then vehicle can access it, or truck and sedan, which are subclasses of vehicle, okay, can also call it. Okay, you make sure you use base to refer to superclass. When we're inside of a subclass, we can refer to a superclass with base keyword. Okay, so if you need to refer to something in your superclass, you use base keyword. So in sedan, you refer to it as base dot speed up because the method is in the superclass, right? So you use base dot speed up. It refers to the speed up method in vehicle, the superclass or the base class. So let's look at the syntax for calling the superclass constructor. So the above code shows that a sedan inherits from vehicle, right? And the sedan constructor here calls the vehicle constructor base with one argument, which is speed. Okay, this works as long as vehicle has a constructor with one argument of type double. So even if we don't use base in sedan, it will still call a vehicle constructor. Without an explicit call to base, any subclass constructor will implicitly call the default parameterless constructor for its superclass. Okay, so if you don't put base in there, okay, it's still going to call the same thing. So you can write it like this as well, public sedan and then double speed, which is the same as doing it that way. So the same thing. But this code will only work if the constructor vehicle exists. Okay? If it doesn't exist though, an error will be thrown. Next, let's talk about overriding inherited members. If we wanted to make one more vehicle that operates a bit differently than a sedan or a truck, and if we want to use most of the members in the vehicle, but we need to write a new version of speed up and slow down just for that new class, okay, new vehicle, then we need to override with an inherited method. Okay, we use override and virtual modifiers. So in the superclass, we mark the method in question as virtual. It tells the computer that this member might be overridden in subclasses. Okay, so you have to put virtual in front of it. So speed up might be overridden in subclasses, so we're going to do virtual, put virtual inside there, just to let the computer know it might be overridden in subclasses. So in the subclass, we mark the method as override. It tells the computer, I know this member is defined in the superclass already, but I like to override it with this method. So you override, put override in there. Okay. Next, we want to add one more method to the vehicle called describe. It'll be different for every subclass, so there's no point in defining a default one in vehicle, right? Regardless, we want to make sure it's implemented in each subclass. So we want to add this method to the I automobile interface, but we want this describe to be available to all the vehicles, not just the automobiles. So to do this, we need one more modifier, which is abstract. So in the vehicle class, you write public abstract string describe. This is the vehicle class telling its subclasses. If you inherit from me, you must define a describe method because I won't be giving you any default functionality to inherit. So abstract members have no implementation in the subclass. Okay, let me try that again. Abstract members have no implementation in the superclass. Okay, but they must be implemented in all subclasses. Okay, and the class must be abstract as well. So if one member of a class is abstract, then the class itself can't really exist as an instance. So imagine calling vehicle.describe, right? The method vehicle describe. It doesn't make sense because it doesn't exist. Okay, so this means that the entire vehicle class must be abstract. Okay, so label it with abstract. So once we write the abstract method and mark the class as abstract, we'll need to actually implement it in each subclass. So for example, you'll have to write it like this in sedan, okay, the describe method. So spend a minute or so and take a look at this code here. Okay, so you have public override, and then the data type string, and then the method name. Okay, so to make it clear that this describe method sedan is overriding the method, the described method in vehicle, we'll need to name it override. All right, so that brings us to the end of this PowerPoint video. It's very important that you go on to do the class activities so that you can understand what we have learned in this video.